Hello everyone, Masat Manav, and I'm here with a new video in which we're gonna continue our previous topic that was on matter in which in our previous video we discussed about the impure substances, pure substances, elements, compounds, mixtures, and in this video we're gonna continue that chapter in which we're gonna talking about solution, suspension, colloidal solution, concentration of solution, and solubility, and also about alloys. So without wasting any time, let's start a topic. In our previous video, that was also on that is matter around us pure that I uploaded yesterday. We talked about about solutions, in which in our previous video I talked about solution. We discussed that topic. So we're not gonna discuss that again. But in a previous video, we understand what is the meaning of a pure substance, what is impure, what is mixture. There are two types of mixture: heterogeneous mixture, homogeneous mixture. In this video, we're gonna start with alloys. Starting with the definition. Alloys are the mixture of two or three substances or elements, and we cannot separate them with the help of any physical change, or sorry, a physical reaction or a physical process. But alloys are considered as a mixture. Example of alloy is brass, in which 30% it is made up of zinc and 70%, approximately 70% of copper. And the main point is that why it is considered as a mixture. So it is considered as a mixture because it has a variable composition of its constituents. In the last video, we understood the topic compounds. What is the meaning of compound? When a compound is a substance that is made from two or three elements by joining them with the help of a chemical bond, and we cannot separate them with the help of any physical change or physical reaction. But it has a constant composition of its constituents. In a previous video, I took the example of water, H2O, in which we have two molecules of hydrogen and one molecule of oxygen. The ratio becomes 2:16. And at the end, after cutting, it comes 1:8. So whether if you're gonna take the water from sea, from ocean, from a tap, from your tank, home tank, the ratio will be 1:8. If you're not gonna keep that ratio 1:8, then you're not gonna get water, you're gonna get any other chemical. I hope you understand what I wanted to understand you, to make you understand the topic. So alloys are considered as a mixture because they have variable composition. After alloys, now we are shifting to a new topic that is about suspension, colloidal solution. Starting with colloidal solution, it is a mixture in which particles are uniformly spread out. We have three types of solution we can see. One is suspension, second is colloidal solution, third is our simple solution. A solution is homogeneous, means the solute uniformly get dissolved in it in the solvent. Second, suspension. Suspension, it is considered as heterogeneous. Third, colloidal solution. It is considered as heterogeneous mixture, but it seems like a homogeneous. Why? Now understand the definition. Listen it carefully. A colloidal solution is that solution in which particles are uniformly separated into the whole our mixture. You can say in the whole mixture. Yeah. So the suspension, I was saying, we were talking about the colloidal solution. If you take colloidal solution, if you take solution, we have solute and solvent. But here we don't have solute and solvent. Instead of solute, we have dispersed phase. It is the name is dispersed phase, and the second, that is solvent, it is named as dispersed medium. Yeah, it is considered, we can say it is named as dispersed medium. So we have three states of matter, as you know: solid, liquid, and solid, liquid, and gas. So when you take solid as a dispersed phase and gas as a dispersed medium, then it is named as aerosol. Aerosol. So there are many terms: emulsion, we can say foam, and gel. All these are colloidal solutions. So now after this, we're gonna talk about suspension. In suspension, in suspension solution, our solute do not properly mix with the solvent, and that is the why what's the sorry, I got obstructed. What is the reason behind that it's not get dissolved properly in it? The reason is the size of the solute. It is more than 100 nanometer. If you take the example of solution, and it's a simple solution, the particle in it is more than 0 nanometer. I think not 10, I think, or approximately 10. If you take about suspension, it is greater than 100 nanometer. And if you take the example colloidal solution, the size of solute in it is approximately between the range of our suspension solute and our solution solute. So after this, now we're gonna talk about the left is concentration of solution. Concentration of solution. Concentration of solution. Concentration of solution is the solute getting dissolved in a particular amount of solvent. And what is the solubility? To understand solubility first, we first will have to understand what is the difference between saturated solution and unsaturated solution. So saturated solution are those in which solute is unable to dissolve in solvent due to of excessive amount of solute. If you are pouring, we can say, salt in water, after some time it's not gonna dissolve, it will stop dissolving in it. That is a saturated solution, and the opposite of the same is unsaturated solution. So now we are going to discuss solubility. Solubility means it is the maximum solute can be dissolved in a particular amount of solvent at a particular temperature. That is solubility. Now we are going to understand the topic of Tyndall effect. Tyndall effect is the effect which is considered, which is, I mean, it has been named after the discovery. I mean, the scientist who discovered this effect is named on him. I don't know the name of scientist, but I know this fact. This real fact. So Tyndall effect is the separation, or we can say not separation, spreading of the beam of a light. If you have a room in which there is only a small hole in which sunlight is coming, you're gonna see many particles, dust particles through that beam of light. That is Tyndall effect. In suspension, you're gonna observe Tyndall effect. in suspension. Yeah, you're gonna see the Tyndall effect. And in our that is colloidal solution, you're also gonna observe Tyndall effect. Why? Because they're heterogeneous mixture, and in heterogeneous mixture solute doesn't get dissolved properly in the solvent. So there are particles that separate the beam of light, and that process is known as Tyndall effect. Now we're gonna talk about stability. Our homogeneous mixture is not stable. You're not gonna see any salt particles settled on it. But if you will keep our uh, suspended solution without disturbing it, you're gonna see that layer of the particles settled at the bottom of the beaker. And in colloidal solution, you're not gonna see that because most of the particles are dissolved in it. Now we're gonna talk about the mass by mass percentage, concentration percentage. What is the formula of mass by mass concentration percentage? It can also be it can also be in the terms of volume, and it also can be in the terms of gram in or mean gram mean mass, and it also can be ml. So the formula for it is mass of solute divided by mass of the whole solution. Mean how you're gonna find the mass of the whole solution by adding the mass of or the volume of solvent and solute. You're gonna get the mass or the volume, total volume or mass of the solution, and you're gonna multiply it by 100. You're gonna get your percentage. So I hope, friends, you have understand this topic. In our previous video, I made you understand some of the basic topics, and now we have done our advanced things too in this video. So I'm gonna meet you tomorrow in the next video with a new interesting science topic. Until then, stay safe. Thank you very much.